So guys, Mr. Hanson here, making another one of my repeat videos, so bear with me here. Trying to get you guys all straight on this new unit. So it's 5.3 triangle congruence using SAS, side angle side. Let's jump right to it. So we have the essential question, what does the SAS triangle congruence theorem tell you about triangles? It tells you that if you have two sides and the included angle, so we just did ASA, now we have kind of the opposite two sides with the angle in between. If those are congruent to two sides and the included angle of another triangle, then the whole thing is congruent. The two triangles are congruent. Yeah, I don't mess with this. So justifying SAS. We know that we could, construct this, and we can always do this. So if you have the tools for that, go for it. I'm just going to assume you don't, and we're just going to move past them and give you what you need. But again, on all these, there's always more digging you can do. So this diagram illustrates one step in a sequence of rigid motions that's going to map the triangle DEF to ABC. Describe the sequence. So you could translate DEF, so that point D maps to point A, then rotate DEF 180 degrees counterclockwise about point A. Point E will map to point B, and then DE will be equal to AB. So then if you take a look at what that would look like, right, you'd be all matched up. So then you would reflect, so you'd be all nice and tight to it, and then you'd reflect over, and everything would be congruent. So they are congruent because you can sequence of rigid motions. It all comes back to rigid motion. So yes, we're doing all this crazy stuff now, but if you could still rigid motion it, you could still prove they're congruent. So this is just a shortcut. So deciding whether triangles are congruent using SAS. So two sides in the included angle of one triangle are congruent to two sides in the included angle of another triangle, then the triangles are congruent. Get this down. You really want really good notes for this section. So look for congruent corresponding parts. So in this situation, we're going to run into triangles that are not congruent. So we can see that because, if we look at 20 and 19, and 20 and 19, the included angle should be 45 degrees or 43 degrees, and they're not the same, therefore it's not congruent. All parts need to be congruent. In this case, we're looking for SAS. So you need the side, angle, side. You see how the sides meet up, and the angle is where they'd meet. So here's an opportunity for you to give it a shot. You might want to pause it real quick. Now if we take a look, we have a side, we have a side, we have a side, we have a side. We have an angle, and we have an angle. Well, I'm not going to fill in all these lines, but you can clearly see that the two sides and the included angle are all congruent, therefore the triangles are congruent. Bam! Alright. Here's one for you. Pause it, try it, but yes, these will be congruent. Proving triangles are congruent using SAS. Write the proof. So, there's real world objects, and some of these real world examples just aren't great. But anyways, so we're given that line segment BD is the perpendicular bisector of AC. So that means these two sides are now congruent. Right? Prove that BDA triangle is congruent to BDC. Well, AD is CD, which is what I said, which means that they are congruent, and BD and angle C are a shared line, so that means these are congruent. Now, is this angle congruent where they meet? They're obviously 90 degrees. So you could write that. You could talk about reflexive property, but anyways, either way, this is SAS. So here you go here, and this one's going to be one of our bow tie vertical angle friends. So you're given that CD bisects AE and AE bisects CD. So then you know that this is congruent, you know that this is congruent. Now, just looking at this without doing anything else, you know that these two angles are congruent, right? Vertical angles. So side, side. These are different color. Side, side, angle, side, side, angle. This kind of looks like something. I don't know what it looks like a face, like a nose. But anyways, the sides meet. The angles that are shared are congruent. Therefore, everything is congruent. Here's your turn. This is going to have a reflexive property in it, right? Right here. So the AC is obviously congruent to itself. Given that AB is congruent to AD and angle measure 1 is congruent to angle measure 2, you clearly can see that you have a side, side, angle, side, side, angle. Congruent. Explain why the corresponding angles must be included angles in order to use the SAS triangle congruence theorem. Well, if the corresponding angles are not included angles, then there's more than one possible angle. So if you try to do like side-side angle or something else and not follow these rules for SAS, you're not right. You're wrong. So be right. Be right. Practice. This was quick. Do what you need to do. I think the big thing here is just you're looking for that setup, and the book has a ton of good practice examples and some algebra ones too. So you got to solve these two column proofs. You can give your best at it. I don't even gonna sweat them, but you definitely want to set them up and place the givens at least, and then you're just logicking your way through it. Some higher stuff. So really, guys, for ASA, we did ASA, we did CBC, now we're on SAS. Good notes. Side, side, angle, side, angle, side. It's where they meet. Angle, angle, side. It's a little different. As long as those pairs are congruent, the whole thing's congruent. So thank you guys for watching. Hit that like button. Hopefully this made sense. I'll see you later. Production quality, I know on these last 3 videos has been not good, but I'm literally 20 minutes away from you guys starting class, and I'm not done because I had to redo all these.